Something is happening right now that has every space agency on edge. The interstellar object known as 3I-ATLAS, the third visitor ever confirmed from beyond our solar system, just did something no one thought was possible. It changed course. Not slightly, not subtly, but in a way that breaks every known law of celestial mechanics. For the first time in history, the International Asteroid Warning Network, a United Nations-endorsed global defense coalition, has begun tracking an object from another star system. But why now? Why this one? Because new data suggests that 3I-ATLAS isn't where it's supposed to be, not according to NASA's Jet Propulsion Laboratory, not according to orbital predictions, and not according to the fundamental rules of physics. If this object really altered its trajectory while near the Sun, then what we're witnessing may not just be an astronomical anomaly, it could be intentional. The International Asteroid Warning Network, or IAWN, has one purpose: to detect and prepare for threats that could endanger life on Earth. It's a coalition of the world's most powerful observatories, from NASA and ESA to China's Purple Mountain Observatory. Until now, it has only ever monitored near-Earth asteroids, debris born within our own solar system. But in late October 2025, the IAWN made a stunning announcement. For the first time ever, it would begin tracking an interstellar object 3I-ATLAS. The official reason: to improve astrometric precision on cometary bodies. But the timing was suspicious. Just days earlier, 3I-ATLAS had vanished behind the Sun, and independent astronomers began reporting small deviations in its expected position. It was supposed to reappear along a predictable arc. Instead, the math stopped working. Avi Loeb, Harvard astrophysicist and author of the Loeb scale, had already rated 3I-ATLAS a 4 out of 10 on the likelihood of being artificial. Then, after these new anomalies, the IAWN quietly upgraded it to a priority target. Hundreds of telescopes were redirected to track it, as if Earth itself was preparing for something we weren't supposed to see coming. The first hint of something wrong came from an independent group of astronomers known as Earth Exists, a small but respected research collective. They compared live telescope data with JPL's Horizon System predictions, and what they found made headlines overnight. 3I-ATLAS wasn't just off course by a few hundred kilometers. It was 1.1 million kilometers away from where it should have been, roughly 3 times the distance between Earth and the Moon. The displacement wasn't random. The object's distance remained consistent, but its sky position shifted laterally, as if it had moved sideways through space. This breaks orbital mechanics. Comets can drift forward or backward due to outgassing jets of vapor that act like natural thrusters, but they don't move laterally. To make this happen, an immense external force would be needed, or an internal one. Even the largest comet ever recorded, Hale, Bopp, couldn't achieve such precision or power. Yet somehow, 3I-ATLAS had done it. If it had shifted its orbit intentionally, then someone must have noticed before the rest of the world. That's when attention turned to NASA and JPL. As early as September, NASA's Mars orbiters had been perfectly positioned to photograph the object at close range during its solar flyby, but those images have never been released. Not a single frame. Internal sources claim the data is being analyzed, but others suspect something more deliberate: censorship. If those images show structural geometry or light behavior inconsistent with a natural body, NASA would have every reason to delay public release. In one of his recent publications, Avi Loeb mentioned that 3I-ATLAS exhibited an antitail, a jet of material pointing toward the Sun, an extremely rare phenomenon. But after the Mars encounter, the tail flipped, suddenly flowing away from the Sun again, as if the object had reoriented itself. No natural comet has ever reversed its jet direction so cleanly. And yet, despite the strangeness, NASA insists it's routine cometary activity. Still, the question remains. If it's routine, why is the asteroid defense network involved at all? By the end of October, new tracking data confirmed what everyone feared: the deviation was real. Over a span of 19 hours, the positional discrepancy widened by over 4 arcminutes, equivalent to hundreds of thousands of kilometers. According to orbital analysts, maintaining that drift would require a lateral velocity of nearly 4 km/s, more thrust than some of our own deep space probes could ever produce. Theories exploded across the community. Some said it was outgassing. Others blamed solar wind. But solar wind doesn't push sideways. If the data is correct, 3IATLAS would need a propulsion system capable of sustained acceleration and precision maneuvering. Meanwhile, the IAWN's workshop to train astronomers on tracking unpredictable cometary behavior filled within hours. Behind the scenes, NASA's Planetary Defense Office quietly elevated its monitoring level, the same tier reserved for potentially hazardous asteroids. The irony: the object was moving away from Earth, not toward it. So why treat it like a threat? Some believe the answer lies in something even stranger: it may be planning another turn. Just when astronomers thought the anomaly had stabilized, 3IATLAS changed direction again. But this time, it wasn't just a slight deviation, it was a full correction. Ground-based observatories in Chile, Spain, and Japan detected a secondary deflection, smaller than the first, but perfectly aligned with the object's original trajectory, as if it had corrected its own path. This was no random drift. The movement was symmetrical, calculated, and exact, the kind of correction that a spacecraft would execute after an automated navigation check. The IAWN issued an internal alert marked pattern recognition event, meaning the behavior matched no known natural phenomenon. At the same time, the European Space Operations Center, ESOC, released an encrypted update to its member agencies confirming that 3IATLAS had produced measurable acceleration inconsistent with gravitational influence. In simple terms, the object had fired something. But fired what? When the Very Large Telescope in Chile analyzed its infrared emissions, it discovered a sudden spike in thermal radiation, a burst lasting 12 minutes, followed by complete cooling, as if a controlled engine had ignited, then shut off. Whatever 3IATLAS was, it had just proven it could move on its own. The moment the data went public, every space agency scrambled. NASA doubled its monitoring schedule. China reactivated its U-22 radio array, normally used for lunar missions, to track deep space frequencies coming from the object's vector. The European Space Agency deployed emergency protocols from its Planetary Defense Office, a move typically reserved for imminent impact events. Officially, this was to ensure coordinated observation. Unofficially, it was panic. Scientists from Caltech and the University of Tokyo began comparing 3IATLAS's acceleration pattern to known artificial propulsion systems. What they found was eerie. The heat curve of the burst didn't match any chemical reaction or known ion drive. Instead, it resembled a magneto-hydrodynamic acceleration signature, the kind produced when charged plasma is guided by electromagnetic fields. It's the same technology humanity has only theorized for interstellar travel, and it wasn't just propulsion. The object's rotation rate, previously stable, began to fluctuate in harmonics, repeating every 247 seconds. At first, astronomers thought it was tumbling, but the pattern was too precise. It was communicating through motion. With each new observation, the International Asteroid Warning Network expanded its scope. What began as a scientific collaboration was now operating like a defense task force. The object's new heading pointed not toward interstellar space, but toward the outer planets. Specifically, its adjusted trajectory intersected with the orbital path of Jupiter. Analysts calculated that within months, 3I-ATLAS would pass dangerously close to the gas giant, within its magnetosphere, a region capable of generating immense energy. If this was a coincidence, it was an astonishing one. But if it wasn't, then the object was preparing for something deliberate. A gravity assist, the same maneuver spacecraft used to gain speed or change direction using a planet's motion. That was the moment global monitoring reached what NASA calls Level 3 contingency. It meant the object's movement was active, intentional, and increasingly unpredictable. Yet, despite the rising tension, something even stranger began to happen. The frequency of radio interference across Earth's observatories started synchronizing, all matching 3I-ATLAS's rotational pulse. The planet itself was beginning to resonate with the object's signal. Then, without warning, every observatory tracking 3I-ATLAS went dark. In less than 10 minutes, telemetry from Hawaii, Chile, Italy, and South Africa simultaneously froze. The Deep Space Network lost contact. Even China's radio arrays reported total silence across multiple frequencies. When the data streams resumed 47 minutes later, they all showed the same thing. 3I-ATLAS had vanished. It wasn't destroyed. It wasn't hidden by the sun. It was gone, missing from every registered coordinate. But a faint echo remained, a low-frequency hum, undetectable to the human ear but measurable by sensors, pulsing across the network once every 247 seconds. Scientists first assumed it was background interference, but the timing was too perfect. Each pulse coincided with the object's last known spin period, as if the signal was still out there, bouncing across space, echoing its final position. The IAWN officially marked the event as Interstellar Signal Anomaly 2025-11, classifying it under restricted access. But one detail leaked. In those last 47 minutes of blackout, telescopes briefly registered a flash, faint, directional, and aligned perfectly with Jupiter's orbit. The object hadn't disappeared. It had jumped. In the hours following the blackout, chaos erupted within the world's astronomical community. The International Asteroid Warning Network released no statement. NASA remained silent. China's Deep Space Network issued a single line of data before wiping its archives clean. Tracking anomaly terminated. Object unobservable. For a full week, the world had no idea where 3I-ATLAS had gone. Then, late one night, the James Webb Space Telescope detected something faint. A flash of reflected light moving at impossible velocity, streaking just beyond Jupiter's orbit. When analysts compared the position with orbital mechanics, the results stunned them. The object hadn't decelerated or drifted. It had performed what physicists call an instantaneous vector relocation. In simple terms, it had changed position faster than the speed of light would allow. And that shouldn't be possible. For days, scientists tried to rationalize the data. Maybe it was a sensor glitch. Maybe it was background radiation. But then came confirmation. The European Space Agency's Gaia Observatory, orbiting 1.5 million kilometers from Earth, picked up an identical reflection exactly 247 seconds after Webb's detection. The timing was exact. The signal had jumped, as though the object had duplicated itself across spacetime using the same resonant frequency it had been broadcasting for months. Every time that pulse was detected, it didn't fade, it multiplied. It was as if 3I-ATLAS had learned how to use gravity itself as a bridge, moving through the very fabric of spacetime. Then came the most disturbing discovery of all. The IAWN Command Center in Vienna received a priority transmission marked Level Omega. It contained a partial data stream reconstructed from the blackout window, the missing 47 minutes when all observatories went silent. When decrypted, the data wasn't telemetry or images. It was binary, a structured transmission embedded inside the network itself, synchronized with 3IATLAS's pulse sequence. When decoded, it formed coordinates, but not for space, for time. The location matched the orbit of Jupiter, but the timestamp didn't. It pointed forward exactly 6 years into the future. At first, analysts dismissed it as corrupted data, but as the reconstruction continued, something horrifying became clear. The coordinates weren't for Jupiter. They were for Earth, a trajectory marker precise to within kilometers, indicating where 3I-ATLAS would intersect with our planet's orbital plane in the year 2031. The object hadn't escaped the solar system. It had set a return point. The file was immediately locked under the Asteroid Hazard Level 10 protocol, the same classification used for civilization-level threats. Every national space agency denied its existence. And yet, 3 months later, amateur astronomers in Australia began picking up faint radio echoes repeating the same 247-second pulse, but this time from inside the asteroid belt. The signal wasn't drifting away anymore. It was circling back. That was when the asteroid warning network went dark permanently. All data, all public feeds, and all open observation logs vanished from the internet. The official reason: system restructuring. The truth, unknown. But insiders claimed that a private network of encrypted observatories was established, operating outside any government jurisdiction. Its code name, Project Helios. Their mission, to track whatever 3I-ATLAS had become and prepare for its return. Because maybe the object wasn't just maneuvering through space. Maybe it was mapping it, studying our gravity, our orbit, our resonance. Maybe it wasn't fleeing from something at all. Maybe it was waiting for alignment. Now, every 247 seconds, a faint pulse still echoes across the solar system, so weak it blends with the cosmic background, but strong enough to remind us that the story isn't over. The world may have forgotten about 3I-ATLAS, but the universe hasn't. So if this story made you question what's really moving out there, what intelligence could be guiding something across the stars, don't look away.